Next chemical property of alkynes is oxidation reactions of alkyne. In different oxidation conditions, alkynes give different oxidation product. So first reaction which we will be going to study in oxidation reaction, that is oxidation with air or oxygen. So what is happening in this condition? First of all, this reaction is also known as combustion reaction. In the presence of oxygen, alkynes undergo complete combustion to form CO2 and H2O. So when there is formation of CO2 and H2O is taking place in the presence of oxygen, then this reaction is known as combustion reaction. In this, large amount of heat and light is produced. So what is happening in this condition? When CH triple bond CH in the presence of oxygen, so you have to balance the reaction. First of all, what will be the product which will be formed? This is combustion reaction. So in this alkyne will completely combust in the presence of oxygen. So there will be formation of CO2 and H2O will takes place. So you have to balance the reaction. So in this will be 5 molecule of oxygen will be taken. There will be 2 moles of acetylene. So there will be formation of 4 moles of CO2 and 2 molecules of H2O will be taking place. In this reaction is highly exothermic. So in this, large amount of heat is released. So how much heat is released when acetylene is combusted in the presence of oxygen? Around 1300 kilojoule per mole of energy is released. So this is highly exothermic reaction. In this, large amount of heat is released. Under moderate temperature and pressure condition, when acetylene is heated in the presence of oxygen, then there is release of yellow luminous sooty flame. It is because of the high carbon content is present in the acetylene in comparison to hydrogen. Because of that, this yellow luminous sooty flame is produced. But in high pressure conditions, when this acetylene is heated in the presence of oxygen, there is a blue luminous flame is produced. This is also known as oxyacetylene flame. This oxyacetylene produce very high temperature of around 3000 Kelvin temperature, which is used for cutting and welding of metal. Second oxidation reactions of alkyne is done by the help of oxidizing agent, that is oxidation by cold and dilute KMnO4. KMnO4 is oxidizing agent. So alkynes are readily oxidized in the presence of cold dilute KMnO4. So what is happening in this case? In the presence of cold and dilute KMnO4, there is formation of alpha dicarbonyl is taking place. So in this case, the product which are formed, example 1,2 dialdehydes or 1,2 diketones or 2 oxoacids, or it can also be known as 1,2 dioic acid. So in this case, there is cleavage of carbon-carbon pi bond is taking place, by which there is formation of carbon double bond O is taking place at 1,2 position. It means at the carbon which are triply bonded to each other. So in this case, if there is terminal alkynes are present, so what is happening if there are terminal alkynes? R C triple bond CH. So in this case, this part, this CH part which is triply bonded with this system, this CH part will oxidize in the presence of cold dilute KMnO4, and there is a formation of COH will takes place. So this will be formed, that is carboxylic acid, whereas this part will oxidize to, that is RC triple bond, this part will oxidize to carbonyl compound. It means there will be formation of C double bond O is taking place. Let's see how the oxidation reaction is taking place in the case of terminal alkynes. Example CH3 C triple bond CH. This is terminal alkyne. So in the presence of nascent oxygen which is released by the KMnO4. When KMnO4 is reacting with water, so there is release of nascent oxygen is taking place. This reaction is shown in the case of alkenes. 298 Kelvin to 300 Kelvin. So the temperature of the reaction medium is very low. In this case, there will be cleavage of the pi bond is taking place. So there will be formation of this part will form carboxylic acid, whereas this part will form carbonyl compound. So there will be formation of CH3, C double bond O, COOH. So this compound will be found. What will be the IUPAC name of this compound? 1, 2, 3. This is principal functional group. So it means that this will be treated as side substituent now. So what is the name of this side substituent? 2-oxopropane 1-oic acid. On further oxidation in the presence of cold dilute KMnO4, what is happening? This part will oxidize to CO2, whereas this part will oxidize to carboxylic acid. This part will oxidize to carboxylic acid and this part will be converted to CO2 on further oxidation. So there will be formation of CH3COH, that is acetic acid is taking place. Whereas in the case of non-terminal alkynes, there is formation of diketone is taking place. So what will be the reaction in this case? This is non-terminal alkyne. So in the presence of nascent oxygen, cold dilute KMnO4 98 to 300 Kelvin. So there is formation of CH3. This pi bond will be broken. There are two pi bonds which are broken, whereas the sigma bond will remain intact in this system. So there will be formation of C double bond O, C double bond O, CH3. What will be the name of this compound? This is diketone, butane 2,3 dione. So this compound will be obtained. This is diacetyl. The common name of this compound is diacetyl. Acetylene is oxidized in the presence of cold dilute KMnO4. Temperature condition is 298 to 300 Kelvin. So what is happening? There will be formation of 1,2-dialdehyde is taking place. The common name of this 1,2-dialdehyde, what will be the reaction? In this case, there is formation of dialdehyde is taking place. This is glyoxal, which on further oxidation form oxalic acid. Yani 1,2-dioic acid. So what will be the IUPAC name of this compound? This is ethane 1,2-dioic acid. So how this reaction is identifying whether the compound is saturated or unsaturated? Because in the presence of pi bond, the pink color of KMnO4 will decolorize to form MnO2. This MnO2 is having brown color. So when the oxidation is complete, this pink color of KMnO4 will decolorize to form brown precipitate of MnO2, due to which this reaction is used for test for unsaturation. Similar reaction is represented in the case of alkenes. So this reaction is also known as Bayer's test. This unsaturation test is known as Bayer's test because in this case the reagent which we are using is oxidizing agent, which is KMnO4. Next oxidation reaction of alkynes is done by the help of, that is, hot KMnO4. In this case the temperature of reaction mixture will be higher in comparison to that of cold dilute KMnO4. In this case there is complete cleavage of carbon-carbon triple bond is taking place. It means both sigma and pi bonds are cleaved in the presence of hot KMnO4. R, C triple bond, CH. This is terminal alkyne. So the terminal part, that is triple bond CH part, CO2 and H2O is taking place. It means this part will completely oxidize to give CO2 and H2O. Whereas this part will oxidize to give carboxylic acid. It means there is formation of RCOOH is taking place. So let's see the reaction in the case of terminal alkynes. So what is happening in this case? presence of nascent oxygen which is released by KMnO4. When KMnO4, this hot KMnO4 is reacting with water, there will be release of nascent oxygen is taking place. The temperature of this reaction mixture is high in comparison to cold dilute KMnO4, that is around 373 to 383 Kelvin temperature. Because of that, there is a formation of carboxylic acid is taking place. We know that in the presence of hot KMnO4, there is complete cleavage of C triple bond C is taking place. It means both the pi bonds are cleaved and also the carbon-carbon sigma bonds are also cleaved, which is formed between this C triple bond C. So there will be formation of CH3, COOH, and this triple bond CH part will form CO2. So there is formation of this compound is taking place, bond CH3. This is non-terminal alkyne. So there is formation of only carboxylic acid is taking place, not CO2. It is because there is no triple bond CH is present. So what is happening in the presence of nascent oxygen? Hot KMnO4, temperature conditions are same. So there is formation of 2 moles of acetic acid is formed, whereas in the presence of acetylene, when the oxidation is taken place in the presence of hot KMnO4, similar reaction condition, then there is formation of oxalic acid is taking place. This is oxalic acid. The common name of this compound is oxalic acid. Further, it will oxidize to give CO2 and H2O. So there is further formation of 2 moles of CO2 and H2O. This is the balancing of this reaction. First, in this case, what is happening? How many nascent oxygen will be taken? 4 nascent oxygen will be taken. So there will be formation of this compound, and so this reaction is complete. It is balanced reaction. Next reaction, in the case of terminal alkynes, what is happening? How many nascent oxygen will be taken? There are in one acetic acid there are 2 oxygens. So there are 2 moles of acetic acid is formed in this reaction. So the nascent oxygen which will be taken, that is 4. In the case of this, how many nascent oxygen will be taken in this case? 4 nascent oxygen, because each carbon is bonded by 2 oxygen. So there are 4 oxygen. This is oxalic acid. Further, this will oxidize to give 2 CO2 and H2O. So by the help of this reaction, we can identify the position of triple bond that is present in alkynes on the basis of product which will be formed on reaction with alkaline KMnO4. Next oxidation reaction which is shown in alkyne will be represented by reaction with ozone. So what is the reaction in this case? We have studied ozonolysis in the case of alkenes. Similar reaction will taking place in this case. So what is happening in this case? First of all, this acetylene will react with ozone in the presence of inert solvent, that is CH2Cl2. The reaction temperature, that is the temperature of this reaction mixture, is 196 to 200 Kelvin. So what is happening in this case? There is formation of ozonoid is taking place by cleavage of this triple bond. But in this case, there will be single bond, that is sigma bond will remain intact. Only pi bonds are cleaved. So there is formation of ozonoid is taking place, and you know that ozonoids are unstable and explosive. So what is happening? There will be formation of CH, single bond CH. This is ozonoid, and this is highly unstable. So this ozonoid will decompose in the presence of zinc dust and water, and we can also use platinum in the presence of hydrogen. So this is reductive cleavage. This is reductive cleavage. So what is happening in this case? In this case, there is homolytic fusion is taking place. This carbon single bond carbon will remain intact. So the homolytic fusion is taking place. Similarly, this oxygen-oxygen bond is highly weak. Because of that, there is homolytic fission is taking place. Both the oxygen will take away the shared pair of electron. So there will be formation of odd electron is taking place on this oxygen and also on this oxygen. Similarly, this carbon will also having odd electron, due to which there will be formation of carbon double bond O, carbon double bond O, and this oxygen will remove and combine with this zinc. So there is formation of zinc oxide is taking place, ZNO. Because of that, this reaction is known as reductive cleavage. This step of reaction is known as reductive cleavage, because the compound which is formed is having less number of oxygen in comparison to this ozonoid. So what is happening when there is carbon double bond O is formed, then there is condition of diol is represented in the case of product, because this carbon-carbon single bond is remain intact. So there is formation of C double bond O single, C double bond O, H and H. Ethane 1,2 diol. In the case of terminal alkyne, this is terminal alkyne. When terminal alkyne is reacted with ozone in the presence of inert solvent and temperature is 196 Kelvin, there is cleavage of pi bond is taking place, whereas the sigma bond will remain intact. So there is formation of ozonoid is taking place. This is ozonoid, which is highly unstable. In the presence of zinc dust and water, or we can also take platinum in the presence of hydrogen. So what is happening? There will be reductive cleavage is taking place. It means the product which will be formed having less number of oxygen in comparison to this ozonoid. So in this case, how the reductive cleavage is taking place? There is homolytic fission. There is homolytic fission. Similarly, this oxygen single bond oxygen will also homolytic fuse, because we know that oxygen single bond oxygen is unstable, whereas when oxygen form double bond with some atom or with itself, then that bond will be stable in the case of oxygen, whereas oxygen single bond oxygen is unstable, which is the reason of homolytic fission in the case of oxygen single bond oxygen. So what is happening? This oxygen single bond will also homolytic fuse. So there will be odd electron coming on both the oxygen and also odd electron on both the carbon, whereas this oxygen will be removed and combined with the zinc. So there will be removal of ZNO and the formation of what is happening? C double bond O, C double bond O, and this C single bond C is remain intact. So there is formation of CH3, C double bond O, CH double bond O. This is aldehydic part, this is a ketonic part. So what is the name of this compound? 2-oxopropanol. So this is the compound which will be obtained. Similar reaction will be represented in the case of non-terminal alkynes. So by the help of ozonolysis, that is the compound which will be formed, we can identify the position of a triple bond present in the compound.